Hello friends, our today's problem is find the net force on any one charge out of 4-point charges rest at corner of a square. So let 4 charges 1, 2, 3 and 4. These point 4 charges are resting at corner of a square. Let side of square is A, that is side of square. Now our target is to find net force on any one charge. Now we target this point charge and we have to find net force on this charge due to these 3-point charges. Friends, we all know about Coulombs electrostatic force, that is Fe is equal to K Q1 Q2 upon R square, where Q1 and Q2 are charges and R is distance between these two charges. Now friends, according to this formula, the force between these two charges is given by K Q square upon A square, because distance between them is A. Now let direction is in this direction is the x-axis, or we can use unit vector I cap, and direction in upside is along y-axis, or we can use here j cap. Now friend, the direction of the force between these 2-point charges will be I cap. That is force between these 2-point charges. Now similarly, force between these 2-point charges will be K Q square upon A square. The magnitude of force remains same between these and between these, but direction is different. Now here we can see that the point charges are same in nature, so the nature of force is repulsive. Let we take here the direction of force in this, so direction of force between these two charges will be this. Along this direction is negative of j cap, so direction of this force is negative of j cap. Now friend, we calculate the resultant force due to these two forces. Let one is along in I cap direction and one is along in negative j cap direction. The angle between these two forces are 90 degree or right angle. So the resultant force between these is given by, in this direction, we all know about the resultant force, that is equal to F net is equal to F1 square F2 square plus 2F1 F2 cos theta. Here theta is 90, so cos 90 value will be 0, so this term will be 0, and we forget about here square root, so resultant value will be square root of, we can see here that the magnitude of these two forces are same, so F1 and F2 are equal, so we can write 2F square, which is equal to root of 2F. So our resultant value root of 2 kq square upon a square. And direction, this is our direction of resultant force. We can find the direction easily. This angle is 45 degree. So direction of this is equal to I cap cos of 45 and plus of j cap sin 45. Here j cap is negative, so this value will be negative. Resultant direction will be I cap upon root 2 minus j cap upon root 2. We calculate the force between these 2 point charges and these 2 point charges and resulting force between them. Now 1 point charge is left. Now force between these 2 point charges is to be calculated. The distance between these 2 point charges is root of 2a, which is diagonal of a square. Now the term of magnitude will be, this is our third point charge and this is our first point charge. Distance between them is root of 2a. According to Coulombs electrostatic force will be K charges Q1, Q2, which is equal to each other, that is Q, and distance between them is root of 2a, so its square 2a square. Now direction. We all know the direction which we explained in our previous section, that is same for this. So direction is I cap upon root 2 minus j cap upon root 2. Resultant direction value of resultant force is equal to kq square upon 2a square. Here root 2 is taken outside, so this will be 2 root 2 and I cap minus j cap. Now force due to these 2 point charges is this value. So we write it here, F double prime is equal to kq square upon a square. If we take this root 2 and this root 2 outside, then this root 2 will be cancelled. So resultant force will be kq square upon a square. I cap minus J cap. Now these two forces are along to each other and angle between them is 0. So resultant force can be found by adding them. So our final expression will be, if we take common kq square upon a square, I cap minus j cap, this value is common value and different value is 1 upon 2 and here root 2 and plus of 1. This is our resultant force on fourth point charge due to these 3 point charges.